Hey there! Welcome to the CS Flatmates, where computer science meets fun. If you've ever felt like OS concepts are harder to crack than a coding interview, don't worry. I've got you covered. Today, we're diving into what is process and thread. Trust me, by the end of this video, you'll understand without pulling an all-nighter. So let's jump right in. What is a process? A process is a program in execution. Think of it as an independent entity that has its own resources like memory, registers, and files. Example: imagine you are working on MS Word while listening to music on Spotify. MS Word, one process. Spotify, another process. Both are separate, have their own resources, and run independently. Key points: a process is an independent unit of execution. It has its own memory and resources. Processes do not share data with each other directly. What is a thread? A thread is a smaller unit inside a process. Threads share resources of a process and help in multitasking. Example: inside MS Word, multiple things happen. Typing, one thread. Auto-saving, another thread. Spell checking, another thread. All these tasks share the same process, MS Word, but work separately to improve efficiency. Key points: a thread is a lightweight unit inside a process. Threads share the same memory of the process. Helps in parallel execution within a process. What is the difference between process and thread? Process, an independent execution unit. Thread, a smaller unit inside a process. Process has its own memory space. Thread shares memory with other threads. Process requires inter-process communication. IPC. Threads can communicate easily since they share memory. Process is slow, needs separate memory and resources. Thread is fast, shares existing resources. Chrome browser, one process. Tabs inside Chrome. Each tab is a thread. Real-life analogy. Let a restaurant be a process. Threads are the chefs inside the restaurant, all working in parallel but sharing the same kitchen. What do threads share and what do they have their own? Threads are part of the same process, so they share some things while having their own separate information. So, what threads share? First one code, text section. All threads execute the same program code. Second one, heap memory. Threads can dynamically allocate and use shared memory. Third one, global variables. Any global data can be accessed by all threads. Fourth one, open files and sockets. If one thread opens a file, another thread can use it. Example: think of an office where employees' threads share the same office space, memory. Common documents, global variables. Same Wi-Fi connection, open files, network. What threads have their own? First one, registers. Each thread has its own CPU registers. Second one, stack. Each thread has its own function call stack for execution. Third one, thread ID. Every thread has a unique ID for identification. Example: each employee thread has personal notepad, stack for taking notes, own desk, registers to work individually. Employee ID, thread ID for unique identification. Can a process have multiple threads? Yes, a process can have multiple threads working together. This is called multi-threading. Example: in a video player app, one thread plays the video, another thread loads the next part, another thread handles volume control. This makes the app smoother. Without threads, every action would wait for the other to finish. Key points: multi-threading allows multiple tasks to run in parallel inside a process. Improves performance and responsiveness. Can two processes share memory? Normally no, because each process has its own memory. However, we can make them share memory using inter-process communication. IPC methods like first one, shared memory, second one, pipes, third one, message queues. Example: a web browser process, Chrome, and a video player process, VLC, don't share memory by default. But if Chrome wants to play a YouTube video using VLC, They might communicate through IPC. Which is better, processor or thread? It depends on the situation. Use processes when you need isolation. One crash doesn't affect the other, and security is important. Example, running different applications, Chrome, Spotify. Use threads when tasks need fast communication, since threads share memory, and performance and responsiveness matter. Example, multitasking within one application, Word, video player. Analogy, processes equals to separate houses, each with its own kitchen. Threads equals to roommates, sharing the same kitchen. Final thoughts. Why should we care about this? Understanding processes and threads helps us build faster and efficient software. Threads make programs responsive, smooth experience. Processes provide isolation and security. Next time your laptop lags, remember, it's all about how processes and threads are managed. That's a wrap. If this video helped you, make sure to hit like. It really helps. And if you think your friends could use a little OS wisdom, go ahead and share it with them. And of course, don't forget to subscribe and hit the bell icon so you don't miss out on future videos. See you in the next one. Until then, happy learning.